Good afternoon, good morning, and good evening based on wherever in the world you're joining us from. Please feel free to introduce yourself in the chat and let us know where you're joining us from today. You can also use the react button from Zoom to let us know how you're feeling. So we'll get started with today's webinar. Welcome again, everyone. My name is Madhura Amdekar, and I am a Community Engagement Manager at Crossref. It's my pleasure to welcome you all to today's webinar on building the research nexus with relationship metadata in Crossref. I would like to begin by introducing our speakers for today. Like I said, my name is Madhura. I work as a community engagement manager at Crossref, where I work with scholarly editors, publishers, and editorial organizations to develop engagement programs that help this community to leverage rich metadata for preserving the integrity of the scholarly record. And I'm joining you today from Eindhoven in the Netherlands. Great to see so many of you join us today for this webinar. I'm also joined by three of my amazing colleagues from Crossref, and it's my pleasure to introduce them next. Luis Montilla is a technical community manager at Crossref. Luis was a researcher turned publisher before he joined Crossref in 2022. He is busy educating our community about using the Crossref APIs, collaborating with API users, including Plus subscribers, to help them make the most of our metadata. He also partners with service integrators to realize opportunities to make that metadata richer and their workflows more efficient. Alex Pedar-Valle is a data scientist at Crossref, and he joined us in 2025. He brings over 6 years of experience extracting meaningful insights from data within the research and scholarly publishing sector, applying his expertise to large-scale bibliometric data, aiming to better serve the scholarly community. Prior to Crossref, Alex was at Elsevier, where he was instrumental in modernizing data infrastructure, enhancing the efficiency of massive research data pipelines. His contributions included developing automated data quality checks, creating reusable Python tools, and leveraging machine learning techniques to uncover research trends. He's provided key insights for major reports, contributing to evaluations for the Canada Research Year Program and the NSF Science and Engineering Indicators. He holds an MSc in Quantum Physics and a BSc in Physics. Jason Portnoy is a data scientist at Crossref. He also joined Crossref in 2025. He has experience in bibliometric research and building applications using scholarly data, and has become a passionate advocate for the maintenance and improvement of high-quality scholarly metadata. He has a PhD in information science, studying how scholarly metadata can offer insights into scientific activity and help develop tools to address information overload. He brings experience working at DataCite, OpenAlex, Semantic Scholar, and other organizations concerned with the scholarly communication. Together, this is what we are going to cover in today's webinar. I would first start by talking about what is relationship metadata, what is Crossref's Research Nexus vision, and why relationship metadata is important for building a complete research nexus. Luis is then going to give an overview of the types of relationships in the Crossref metadata schema and how this data on relationships can be retrieved. Alex will then follow up with a presentation on some real-world use cases using this metadata. In the last section, we'll have Jason talking about the matching projects at Crossref and how they contribute to filling the gaps in the scholarly record. Before we begin with the presentations, I just wanted to share a quick note about using Zoom. As you can see, we will not be enabling cameras for everyone, but you can react with different emojis using the react button in the Zoom toolbar. There's a Q&A box at the bottom of your screen. Please use that to ask any Q&As as the speakers go through their presentations. It will help us in monitoring your questions and answering them as well. You can also enable captions in the meeting if you would find that useful. This session is being recorded, and we hope that this will be an enjoyable and productive meeting for everyone, and we expect everyone to hold to the Crossref Code of Conduct. There will be time at the end of all the presentations for Q&A. So we'll first go through all the presentations, and then we'll do Q&A. But I encourage you to enter your questions in the Q&A box while our speakers are presenting so that we can take them up at the end. So let's get started. Before speaking about relationship metadata, I just want to begin with a short introduction to Crossref for those of you who may not be familiar. At Crossref, we are a not-for-profit membership organization that exists to make scholarly communications better. We make research objects easy to find, cite, link, assess, and reuse. Crossref runs open infrastructure to link research objects, entities, and actions, creating a lasting and reusable scholarly record that underpins open science. Crossref's membership today comprises of 24,000 members in 166 countries, and these members have registered 179 million open metadata records with the DOI. Crossref supports a wide range of content types for scholarly and research publications. These include, but are not limited to, books, chapters, conference proceedings, datasets, peer reviews, preprints, reports, and more. Each of these content types has a specific metadata requirement and best practices for registration. Now, all of this metadata is openly available for retrieval via our APIs, and it's used extensively by the scholarly community as well as several downstream services. This makes it a rich and open source of data for analyzing scholarly trends. And today we are going to talk about relationship metadata, which is the focus of this webinar. So to understand the relevance of relationships, let's begin by looking at what constitutes the scholarly record. So traditionally, the outputs of the research and publishing process create a scholarly record. For example, journal articles are one of the outputs of a research process. So the scholarly record would typically refer to collection of journal articles, book chapters, preprints, datasets, or any other outputs that arise from research activities. Over time, the diversity and complexity of research outputs has also increased vastly. Now, each of these diverse types of research outputs have metadata records associated with them, and they contain information about these items such as titles, authors, affiliations, funding information, and more. But looking at the scholarly record as a collection of these independent research outputs is not enough. What's also of interest is how each of these components of the record relate to each other, because it's these connections and links between the different outputs that provide context to these outputs within the research ecosystem. Let's take the example of citations. So many Crossref members provide citations with their metadata records. A citation defines the relationship between the citing item and the item that's being cited. For example, as you can see in this case, this article cites these two other articles amongst others. So these citations link one of the research outputs to the other outputs, and it forms a citation relationship between them. So by following these relationships, one gets to know what work has been done previously and what body of work does the current work build upon. So this emphasizes that research outputs are not independent of each other, but rather there are important relationships between them. And citations are not the only relationships. Research outputs can have other relationships as well. For example, with funding organizations who funded that work, with preprints, with published peer reviews, or where the research was published. And I've just used that last example on the slide as well. So for all of these connections or links between the different research outputs, we can use relation types in the metadata to anchor the research output in the research ecosystem and link to it. And creating these relationships helps build a map of the scholarly research objects that we call the Research Nexus. It's the vision to which we aspire, and this slide shows a schematic representation of this. At the center are all the research objects and the actors of the scholarly ecosystem, and the circles around them represent how they are related to each other and how they act on each other. Together, they form a rich and reusable open network of relationships that connect research organizations, people, things, and actions. A scholarly record that the global community can build on forever for the benefit of society. Therefore, a big part of the research nexus is establishing connections between and among different research objects. And adding relationships to metadata records can convey much richer and more nuanced connections. So if there's more information, more metadata, more relationships, that enables building a complete research nexus. Because the way objects and entities are connected to each other is a very important part of the picture. It's important how they're related to each other, and that provides the context in which they make up the whole research ecosystem. So making these connections creates linked metadata, and it's useful because it establishes associations and context. It helps us answer questions such as who are the authors of a work? What were the affiliations of these authors? Which funding programs supported this work? Was this work updated after publication? Or what reviews, comments, or other commentary exist for that work? So, by answering these questions, it gives this important context, and scholarly metadata can thus act as signals of trustworthiness. It's this interrelatedness that's important, as I've highlighted before, and Crossref plays an important role in collecting, matching, and sharing these relationships. So when relationships between research outputs are not explicit, or when the metadata about these outputs is either incomplete or outdated, there's a risk that the scholarly community is not able to access the most up-to-date information. So by linking different research outputs, relationship metadata plays a key role in preserving the integrity of the scholarly record. The more the more metadata and relationships there are in Crossref records, the more context there is for our members and for the whole scholarly research ecosystem. So preserving the integrity of the scholarly record is enabled when there is complete, comprehensive, and accurate metadata, and it's affected when metadata is unavailable or when it's outdated or when metadata records are incomplete or incorrect. Crossref is focused on providing infrastructure which enables those who produce scholarly outputs to provide metadata and relationships, which are basically evidence and context about how they ensure the quality of their content and how their outputs fit into the wider scholarly record. The community can then use the presence of rich metadata associated with the DOI record as evidence of integrity. With this, I would like to hand it over to my colleague Luis, who is going to take us over the types of relationships and metadata retrieval.
Thank you very much, Mazura. So to continue our conversation about this fascinating topic, so I'm gonna be covering a little bit about what you can find in terms of metadata in our machine interfaces and how you can retrieve this metadata. So from the point of view of metadata retrieval, you have to understand that we are using a controlled vocabulary to define these relationships. So we use always in specific terms for the object and the subject of these relationships. And you can start exploring more or less the kind of elements that you can retrieve in terms of metadata with these links that I will be sharing here. And my colleagues, if you can also share these links in the chat so everybody can have quick access to it. You can just copy and paste these URLs directly in your web browsers, and you will be able to retrieve the information directly from our REST API. Thank you, Alex. So, for example, with this very simple API query that I'm sharing here, you will be able to retrieve a list of works specifically. And then you will be aggregating the type of contents based on the relationship types that we have currently available in our REST API. Now I'm going to start covering more or less the main types of relationships that you will find. This is not an extensive list, but this is some are the most popular ones. Of course, citations, as Majora was showing in her examples, is one of the most commonly established relationships. We established this through our services of reference linking and cited by. So in general, you can find this in our REST API as part of the list of references. And also for those that represent or are part of our Crossref member organization, you can also retrieve forward links. But in general, you can also find some, at the moment incomplete, but a couple of relationships in the forms of with the declarations of sites and is cited by. However, this is not necessarily the most exhaustive list of relationships. But of course, as we were describing in the what composes the research nexus, there are many other elements that can be linked out there, right? So preprints is a common example of things that you can interconnect. So when you have one, for example, one journal article, often you can, if this has a preprint that is preceded by, you can declare, for example, if this that specific journal article has a preprint, or if a preprint is continued by a journal article. And because, so if we continue talking about preprints, because usually a single preprint is not necessarily the final version of it. Sometimes you can find different versions, right, that have been deposited in the preprint servers. These other preprints can also be typed with different relationships. So, for example, you can declare if a preprint has a version or is a version of another work previously existing. And of course, these updates are also, or these relationships can also be declared, for example, not only in terms of if a work has an update, but also the kinds of update, right? One of those is one of the most commonly requested types of updates is if a given work has a retraction. So you can also establish these uh, relationships in the REST API. So, of course, as part of the different work, you can, for example, deposit peer review reports about a specific work and then establish this relationship. So you can extract works depending on whether they have a review. And of course, for example, another commonly requested relationship is whether a work has established a relationship with a funding organization, and even better if a work has a type of funding information related to it, which can be established, for example, through Crossref grant UIs. And in this particular case, this is even more interesting because you can declare not only if a work has funding, but also you can specify a very rich taxonomy of funding. So you can just declare, for example, if a specific type of funding is related to providing equipment or facilities, or if it's just, for example, a price, or if this is covering an APC. So this is the kind of enrichments that you can do through relationships. So now that we have covered more or less a rough list of types of relationships, I can show you more or less how you can start retrieving these. There are different interfaces for machines and for people. This will be a very brief overview of our main interface for machines, which is the REST API. And thank you. You can find the link in our chat. So with this REST API, basically you have available a standard protocol that you can use to connect either a local request or a locally developed application to our web servers. And then basically through this standardized language, you can just request specific information and you can retrieve this in different formats, commonly, for example, in JSON format. Uh, the way this is typically depicted out there is that basically these requests are compared, for example, to a waiter that it's giving you the dish that you ordered in a restaurant. So instead of you just going to the kitchen and cook your meal, just you are doing a request, and then this is brought to your table. With the REST API, it works pretty much in the same analogy. So you are, instead of just retrieving all of the data that we have in our servers, you are just sending a specific request of a specific kinds of works, and you will be getting a response with this specific metadata. In a REST API, you have publicly available a list of, let's say, digital locations that we call the endpoints. You can see here the main list of locations or endpoints in our REST API. Um, the works endpoint is probably the most popular location where we receive requests, but you can see that, for example, you can combine this with requests to the journals endpoint or the funders endpoint, or also members or prefixes, or also types of works. And we can share some material in case that you want to start exploring more or less how to retrieve in general information from the REST API. But for now, I'm going to share a very brief list of examples about retrieving specific types of relationships. So for example, this is the same query that I was sharing before. So as you can see, there are a couple of elements that we can distinguish here. So at the beginning of this string, you can see that we are making queries specifically to crossref.org. That is the base URL of the URL that we will be using in all of our requests. And then you can see that we are making requests specifically to the works endpoint. And then we see that we have a question mark, which is signaling the start of a list of parameters. So we have in this case two specific parameters. We have the parameter rows at the end, which is basically indicating that we are retrieving only not the list of works, but just specifically the total of this summary. And the facet parameter is indicating that we are retrieving an aggregation of the different relationships types. And of course, let us know in the Q&A if you have any issues with this example and we can help you. So this is basically step by step what you are doing when you are uh, writing and sending these requests. And of course, part of these parameters are, for example, we include here the availability of different filters that you have to modify your types of requests, right? So for example, in this case, we are including here one filter, and I'm showing you a table of different options that you can test in your browser right now. So for example, if you include a relationship type and then colon, you can specify the specific type of relationship that you would like to see. With the link that you have available here, you are retrieving the relationship type where a given work is a review of something else. But you can test all of the different options that I'm sharing here in the table. So I can pause for a couple of seconds in case that you want to take note and then start testing a few of those. And also, if you want to share in the chat if you have successfully retrieved something or if something is not working, just feel free to let us know. And we can always go back and I will be monitoring oh, thank you, Jonathan. We will be monitoring the chat in case like someone has questions. So for example, I'm going back to the list of funders. Uh, Once again, this is a very commonly requested endpoint. So you can see, for example, here you can start by funders and then in this case, you can include the funder ID in case that you know it. And then from there, you can add the works endpoint, and then basically you will be retrieving works that have associated a specific funder. I can see that there is a question in the chat. So that's a very rough description of how to retrieve this information. But of course, we might also be wondering how to make this information available, especially if, sure, I can go back for 1 second so you can take a list of this. Uh, I'm also including here at the bottom of the slides. Okay. No worries, Sarah. I'm also including here a list of useful links that you can have at hand. So, for example, here you will have available a link to our documentation where you will find all of the list of our different filters. So, in case you want to play a little bit with those. Thank you, Alex. So, as I was saying, perhaps you in your organization, if you're a Crossref member, you are interested in depositing these relationships to enrich a little bit more the scholarly record with information that you already have available. So, for this, we have two main options available at the moment. So, if you are depositing metadata with us via XML files, you can also do this. And we also have a new interface that lets you deposit this metadata in a friendly manner. Oh, I'm going to show you first one example. In this case, please take note of the documentation. I know that this screenshot is not necessarily the most friendly to read through, but basically what I want to highlight here is that when you are making an XML deposit, you can include the specific types of relationships as part of the same deposit. And here you will have the link to the documentation where you can find specific examples of how to deposit different types of relationships and other examples. So I can paste this in the chat in a minute. But then we recently released this upgrade to one of our interfaces for the Crossref members, which is the Metadata Manager. So with that, you can also make new deposits. Or if you want to start, for example, in this context, start enriching previously deposited records with, for example, with relationships, you can just navigate to this interface, you sign in with your credentials, and then you will be able to navigate and complete your records. For example, in this case, let's start from the example that you want to just deposit things that are incomplete, that you still have gaps in the record. So you will find that a list of the DUIs that you have deposited in the past. And even if you don't find it there, you will find a search box where you can just copy and paste a DUI of a specific work that you know it's deposited with us. And then you will be retrieving this record. If you click this edit button that you will see at the right hand, you will be able to see the different metadata fields that are available. And then once you scroll down to the bottom, you will find this one, which is, of course, the relationships field. And then you will find a drop-down menu where you will find all of the different types of relationships, or at least the most commonly requested at the moment. So you only need to include the type of relationship and the DUI of the related item. So at the moment, this is mostly Crossref DUIs or dataset DUIs for a specific example of data sets. And with that, I will hand it over to my colleague, Alex.
Yep, that's me.
Thank
Hello,
you.
everyone. Thank you, Lewis. Today, I'll be quickly demonstrating 5 practical use cases of our relationship metadata. Basically, how it's being used right now to improve research workflows and unlock new insights. So we'll look at specific examples, and you'll get a sense of how data beyond just the publication itself can make a real difference. There we go. So one of the biggest challenges in research is keeping up with corrections and updates to published works. Our metadata currently holds over 500,000 updated by or update to links. And these allow Crossmark, which is our service that displays these updates, to alert users whenever a work they are reading has changed. So here we've got an example from the journal Plus One, where a correction to the original paper was issued by the journal. And the member has filed this in our relationship metadata. So this created what you see in the gray box here. We see an updated by link, and then it points to a different DOI, which is the DOI of the correction. Then this feeds Crossmark. And so in the PDF or on the website, you get a button that says check for updates. And if you click that button, it will basically check the metadata, and you'll see this little yellow box that says updates are available, and then you've got a link to view the correction. So through this detailed metadata, you can see the type of update, when it was updated, and by whom it was updated. And this helps ensure that research is built on the most accurate and current information possible. If a paper, for example, was retracted, the exact same process could be followed, but then in the record, you'd see updated by, and the type, instead of saying correction, would say retraction. And the box that you get on the web would also say that the paper was retracted. Next, traditionally, as you probably know, peer review has been a bit of a black box. However, with over 1 million peer-reviewed documents that are registered with Crossref, our community is starting to change that. And by linking these reviews to the articles that they evaluate, open peer review is making this activity discoverable, citable, and traceable. This diagram here shows a real example of how rare linking preprints, journal articles, and the reviews they receive, thus creating a transparent and verifiable record of the evaluation process. So at the bottom here, you see we've got 3 peer reviews. One is actually the authors replying to the 2 reviews that they received. This was actually tagged as reviews of the preprint of this paper, and then the preprint is itself linked to the final journal article. This not only recognizes the work of reviewers, but also helps to build trust and rigor in research. And here, something that's really interesting is we can notice that in this case, the peer reviews, the preprint, and the journal article were all deposited by different members under different prefixes. And this highlights that the relationships between different works are not to be self-contained. They are something that's shared by all of the community, and you're free to point to works that you don't necessarily own in your own records. And you can get these much richer networks out of this. As a third example, my colleagues alluded to the fact that one of the relationships that we have is funding, and understanding the impact of research funding is crucial for funders and for researchers. Crossref DOI is currently acknowledged funding in over 29.8 million citations and create 25.3 million links to funder IDs. So this forms a very big network that lets funders trace exactly how their grants have fueled scholarly output. And this chart represents this at a high level. It shows the number of works that have acknowledged a selection of funders versus the average numbers of citations that they've received. Although this chart is really high level and there's a lot of nuance that it doesn't show, it's information such as this that allows funders to see where their investments are making the biggest difference. And it helps researchers also demonstrate the impact of their work and acknowledge the support that they have received. And with grant DOIs that are now being formally accepted as grant IDs in records since I think the start of this year, this information will become even more detailed and easier to leverage, because you won't just get a link from the DOI to the funder or to a pretty opaque grant ID, but you will actually be linked to a detailed record about the grant itself. For decades, scientific papers have told what researchers discovered, but increasingly we need to know also how they discovered it. And this fourth example shows how Crossref relationship metadata is exposing connections that make research more transparent. So imagine here we've got you don't have to imagine it here, but we've got a scientific study. In this example, we're looking at research on immune dysregulation and autoimmunity in persons with Down syndrome. But instead of just reading about the results, you can now link the paper to the actual clinical trial data, which is here the yellow bubble at the bottom. This is a clinical trial that was done in the US, so it's on clinicaltrials.gov. And you can also see that this study relied on 4 key data sets. They are linked on the left. Each of those, 3 of those have a DOI, and the 4th has an accession number because it's something that's hosted on an NIH service. So you can see basically what data the journal article was based on. And excitingly, this research generated two new data sets. They've been published alongside the research, and in the record, you can see that they've linked it with is supplemented by. And then we see another accession number and then another data set with the DOI. So by linking publications to these underlying resources, datasets, code, protocols, uh, our members are not just providing information, they're providing evidence. For example, you can go and review the methodology of the clinical trial, see how it was carried out, and probably give you increased confidence in the findings of the paper. But it goes even further because through Crossref metadata, you can easily see if these data sets were used in other studies and track uptake elsewhere. So you simply have to look at the data sets DOI or look for it in the targets of relationships, and you'll find all of the publications that cite and utilize that specific data. Next, and the final example for today is about citations. We couldn't not talk about citations because they are by far the most common type of relationship that we find in the metadata. There's over 1.9 billion of them present. And so this information can be used for many applications. One of these would be to identify similar publications and make literature discovery easier. There are two key methods to do so, which are called bibliometric coupling and co-citation. Both look at citation signals and assume that if two works have been referenced at the same time, they're likely similar. And if they're cited by the same paper at the same time, they're likely similar. And so to do a little example, we started with the paper, the one highlighted at the top from Nature, titled Papers and Patents Are Becoming Less Disruptive Over Time. This paper referenced 80 others and was itself cited over 600 times. Using the two techniques that I described before, we successfully identified papers that are similar. You can see some examples here. So on the left, we have a paper on large teams developing and small teams disrupting science and technology. And on the right, you've got one about slowed progress in the large fields of science. And at the bottom, there's a more methodological one. But all three are evidently related to our starting paper. And yet we didn't even need to use text searches to find them. Just the relationships were enough. And this to me is a perfect example that the value of these relationships isn't contained in just what's written in black and white. It's about the emergent properties and hidden connections that become visible when you map these relationships at scale. Here we were able to go beyond the direct citations to understand how the ideas themselves are evolving and how knowledge is being constructed. And so I hope my short part of this presentation has shown you the potential of relationship metadata and the value of depositing it with Crossref. Now I'll hand over to Jason for the final part of this webinar.
Thanks very much, Alex, and also Madra and Luis. My name is Jason. I'm also a data scientist here at Crossref, and I'm going to be talking about the matching projects we're doing, which is a big initiative here at Crossref, something we're pushing forward, and we're very excited. And I'll be talking about how it relates to the relationship metadata that we've been talking about specifically. First, just to introduce what we're really talking about here, matching is a process where we take some information about an item and we find a standard identifier for that item that can describe it. This is a very broad idea and it's a broad project. So to make it a little more concrete, and specific, a type of matching is bibliographic reference matching. This is something we already do. We have billions of citations, as Alex just mentioned, that these citations link works together. And more than half of the structured links that we have, of those almost 2 billion links that we have, are the results of the matching that we're already doing. The task here is to take a text representation of the citation as shown on the left, and find its DOI, which creates a citation relationship between the works, one that uses a standard persistent identifier that makes it easy to and persistent to navigate in the Research Nexus. Another type of matching is funder matching. For this, we take the name of a funder, which is submitted as part of the deposit data for a work, and we find the identifier among ROR, which is the Research Organization Registry. It's an open community curated registry that aims to include all of the world's research producing and funding organizations. So in this example, the submitted funder, Millersville University Faculty Grants and Sabbatical Leave Program, is identified in ROR as Millersville University and assigned the ROR ID persistent identifier for that funding organization. And here is a smattering of some other matching tasks. It's not exhaustive, but it is among the matching tasks that we are starting with tackling in our matching initiative here at Crossref. We have reference matching, which I mentioned is taking reference strings and matching it to a DOI. Affiliation matching is similar to funder matching, uses the same ROR registry of research organizations. For affiliations, you're talking about usually the contributing authors will list their organization name and often the location, and we can match that to the ROR ID. Funder matching, as I said, is the funder name, although there can be other data that can be used to help with the matching. Grant matching is the grant metadata that we get can be linked to a grant DOI. Preprint matching is another one. You can take a whole host of information about an article and look for the preprints that represent the same content, basically. And so you in this case you're linking the DOI of a research publication to its preprint DOI. So matching, why bother doing this? The key to this is about the metadata gaps. Now, Luis mentioned a few tools that members can use to submit relationship metadata, which is great, but there's always going to be gaps where we don't have that as our source for the matched identifiers for the different types of relationships. So matching allows us to fill in those gaps on our end automatically using automated methods and at a pretty large scale. So this shows one of the matching tasks that we are already doing. This is references. Again, we have billions of references, and actually over half of them right now are DOIs that are automatically matched rather than those explicitly deposited by Crossref members. So the yellow slice of the pie here are DOIs that the Crossref system has matched to a persistent identifier. It's not going to be perfect. There is that gray area where no DOIs could be found either by the deposits or the automated methods, and that can be for several reasons. One of among those reasons is that there is no DOI to actually match, which can be the case. So these methods generally cannot never be 100% perfect. we can make huge strides in closing these gaps and having a more complete research nexus. Here's another example, and this is something we're not currently doing, but this shows the potential of what we could be doing. And this is matching ROR IDs for affiliation assertions. We have a lot of affiliation assertions by name, and a very small slice. You see that blue-green slice there of 1 million of ROR IDs. We have developed methods that can match 95 million more of these organization assertions to ROR IDs. We've have those as a proof of concept. They're not currently in our data, but this is an example of a gap that we'll be closing with our matching project. So just to talk about the current project, which is still getting off the ground, but we're making good progress on it. Our goals are to build a dedicated matching service that we will use to enrich the metadata as much as possible. So this includes new matching tests as well as overhauling the old matching tests that we are already doing, such as citations that I mentioned, making those more flexible, more open to the community, open source, and centralized in a way that's more transparent. We want to use flexible and transparent matching strategies that are open to the community, and also with potential for community participation in developing new strategies or working on existing strategies. Also, a thorough and open evaluation using evaluation data sets that show how our data is being matched and the performance that our methods are having. And the results of the matches will be made available in the REST API with clear indication of when we've used automated methods. Our current progress, we're starting with funder matching among those tasks. We'll be getting to all of them, but starting with funder matching, we've developed and evaluated a strategy which matches funder names to ROR IDs, and we are designing and building the matching service, which will run behind the scenes on our end and be enriching the data with these new matches. And the key considerations for what we're doing, we've developed a matching strategy that is precise, that prioritizes precision over recall. So we want very few mistakes when matches are found. We consider mistaken matches to IDs to be much worse than methods that don't find every single match. We also want it to be open source, and built on open source methods, and practical, fast and low resource. It could scale to millions of matches. And another key consideration is the ability to correct mistaken matches with help from community input. This is something that's been pretty hard to do with the legacy system that we are looking to replace, but will be much more possible, and a community effort to make sure that everything can be corrected in the case of mistakes, which should happen rarely, but are inevitable. Okay, and that's it for my section. I'll hand it back to my manager. Thank you.
Thank you, Jason and Alex and Luis, for your wonderful presentations. I also want to thank my colleague Amanda French, who's been keeping an eye on the chat and answering questions as they come up. I'm just looking at our Q&A box and the chat. I think most has been actively answered by my colleagues as the others were speaking. But if there are any more questions, please feel free to add them in the Q&A box. We have some time to answer your questions. I just see one question that has come in the chat, which is there an intent to expose the matching API through a REST API? Jason, do you want to take that one?
Which question?
It's in the chat, and Kevin is asking, is there an intent to expose the matching API through a REST API?
I think there will be. We're still discussing that basically. It is the actual matching API will be open source. It'll be possible to run it on your own if you have some technical ability. But there are other considerations with making it completely its own REST API for matching. So we're discussing that. But we'd like your input if you think it would be useful for work that you're doing, to have a REST API available to you specifically for the matching service. We'd love to know your use case.
Thanks, Jason. There was a question earlier from the audience, and I know, Alex, you answered that, but I thought it would be of interest to the wider group. There was a question about whether relationships are all binary, which means that they are subject, predicate, and object. And what if someone wants to record information about the relationship itself? For example, when the date of where a preprint is created or funding is approved. Did you want to elaborate that for everyone present?
Yeah, sure. Yeah, so that was a good question. And the relationships themselves, most of them anyway, because basically all of them that you find in the relation element of those REST API responses, those would all be binary. So basically, the only information you get about them is the DOI or the accession number or something that they point to, and then some metadata about the ID type and who has asserted this relationship, basically. So you don't get much information about the relationship itself, or the grant that it points to, for example. But if that is something that is of interest, so long as the relationship is pointing to a DOI, you would be able to go and access the record from that DOI to probably get what you're after. So the question was about, for example, the date a preprint was created or when funding was approved. This is typically information that you would get in the corresponding record. There are some special relationships, such as update, for example, as I've shown, that do have some more information embedded into them, but those are typically also broken out in a special section of those API responses. So the updates have their own special field where this metadata is exposed. So when you've got more simple relationships that are in the relation, those would all be binary, but some are special.
Thank you for that, Alex. I don't see many more open questions. I think most have been answered. There's a very active chat as well going on. I appreciate everybody contributing there. If there are any more questions, or if anybody wants to add something from my colleagues, if there's anything you'd want to add to elaborate on any of the questions that you've answered so far, that would be useful as well. There's some comments coming in the chat. Thank you for sharing those. Jason, I was wondering whether you wanted to comment on any of the discussion on the matching in the chat.
There's been a few good things, but I don't think I have time to delve too deep into any one thing. There's been some talk about how freeform the funder schema can be in the deposit XMLs, which can create some confusion. I am I'm somewhat aware of this, kind of on the other end of getting the funding XML data that we already have, and I'm aware that it can be a little confusing, but I see there's a working group to work some of these issues out, and looking forward to seeing more about that. Also talking about the matching strategy that we're using for funders. Ted mentioned that he's seen that on ROAR itself. That is the case. ROAR and Crossref have been working together to make to improve their matching strategies for affiliations, and that is live on the ROAR API. You can match affiliation strings to ROAR identifiers. And the strategy that we've developed together is soon to be the default strategy for that. The funder strategy that I specifically have been working on and we're going to implement behind the scenes across all of Crossref's funding data is based on that, but it is a little different. It will be open source. We will be blogging about it, and but it's tuned a little bit differently to the affiliation data just because funder strings can look a little different, and there's slightly different targeting that we want.
Thank you, Jason. I'm not seeing any
Oh,
open
and
question. Yeah,
sorry, Ted asked also. Oh, Ted asked just to let you know, it's the single search strategy was the code name for it in ROAR.
perfect. Thank you for sharing that. Um, like I was saying, I'm not seeing any open questions, and we are almost at time as well. I just want to thank Jason, Alex, and Luis for all of their informative presentations and for their time today. Um, Thank you to all our attendees for attending this webinar. I hope that you found this information shared useful. You can keep the conversation going at our community forum. The link is on the slide. And also, if you have any specific questions, you can contact Crossref via this form. Thank you again for making it today. I wish you all a wonderful rest of your day.